everyone. I'm Katrina Rose Valles. And I'm Katrina May Marcelo. And we are discussing about inelastic collision.
Objectives. The objectives of the experiments are to get the mass, velocity, and the total kinetic energy before and after the collision. To prove the concept of inelastic collision, the kinetic energy is not conserved. To prove that the total kinetic energy after the collision is less than the total kinetic energy before the collision.
Background of the study. Collision. A collision occurs when two or more objects hit each other. When objects collide, each object feels a force for a short amount of time. This force imparts an impulse or changes the momentum of each of the colliding objects. But if the system of particles is isolated, we know that the momentum is conserved. Therefore, while the momentum of each individual particle involved in the collision changes, the total momentum of the system remains constant. The procedure for analyzing collision depends on whether the process is elastic or inelastic. Kinetic energy is conserved in inelastic collision, whereas inelastic energy convert into other forms of energy during an inelastic collision. In both types of collision, momentum is conserved.
Hypothesis. We expect that the heavier the car, the harder to move. The calculated total kinetic energy depends on the velocity of the two cars before and after the collision. The net momentum before and after the collision is equal, but the total kinetic energy is different before and after the collision. Materials. The materials that are needed are toy car, meter stick or ruler, spring balance, stopwatch or timer.
Materials. The materials that are needed are two toy cars, ruler, spring balance, and stopwatch or timer. You can also use your cell phone as your timer. First, using the spring balance, get the mass of the two toy cars in kilograms. Since we have no spring balance, we suppose that the mass of the car A is 0.5 kilograms. The mass of the car B is 0.2 kilograms. Second, mark the starting point of the two cars. Car A to car B. Start the timer as you push the car A. Stop the timer when the two toy cars collide. Measure the distance between the starting point of the car and where the two cars have been collided using meter stick or ruler. Do this in each of the cars. The distance of car A is 46. The measure of car B is 32 centimeters.
Next is to get the velocity of car A before the collision. The given are distance d is equal to 46 centimeter or 0.46 meter, and the time it takes to collide the two cars is 0.46 seconds. The formula of velocity is velocity equals distance over time. Solution. Velocity is equal to 0.46 meters over 0.46 seconds. And if we divide the two, we get 1.1 meter per second. Velocity of car B before collision. Given distance t is equal to 32 centimeter or 0.32 meter, and the time t is equal to 0.46 seconds. The formula to get the velocity is distance divided by the time. The distance is 0.32 meters divided by the time, which is 0.46 seconds. And then we get 0.7 meter per seconds.
Kinetic energy of car A before collision. Given mass is 0.5 kilogram and velocity is 1 meter per second. Formula. Kinetic energy is equals to 1 half mass velocity squared. Solution. Kinetic energy is equals to 1 half times 0.5 kilograms times 1 meter per second squared. Kinetic energy is equals to 1 half times 0.5 kilogram meter per second squared. And the total kinetic energy of car A before the collision is kinetic energy is equals to 0.25 joules. Kinetic energy of car B before collision. Given mass is equals to 0.2 kilogram, velocity is equals to 0.7 meter per second. Formula, kinetic energy is equals to 1 half mass velocity squared. Solution, kinetic energy is equals to 1 half times 0.2 kilogram times 0.7 meter per second squared. Kinetic energy is equals to 1 half times 0.15 kilogram meter per second squared. The total kinetic energy of car B for collision is 0.07 joules. And the total kinetic energy before the collision of car A and car B is 0.32 joules.
Velocity of car A and car B after collision. Given the velocity of car A before collision is 1 meter per second and the velocity of car B before collision is 0.7 meter per second. The mass of car A 0.5 kilogram and the mass of car B, which is 0.2 kilogram. Formula: the velocity of car B after collision minus the velocity of car A after collision is equal to negative velocity of car B before collision minus velocity of car A before collision. The mass the next formula is the mass of the car A times velocity of car A before collision plus mass of car B times the velocity of car B before collision is equal to the mass of car A times the velocity of car A after collision plus mass of car B times the velocity of car B after collision. Solution. Solution. The velocity of car B after collision and minus the velocity of car A after collision is equal to negative 0.7 meter per second minus 1 meter per second. The velocity of car B after collision minus the velocity of car A after collision is equal to 0.3 meter per second. 0.5 kilogram times 1 meter per second plus 0.2 kilogram times 0.7 meter per second is equal to 0.5 kilogram multiplied by velocity of car A after collision plus 0.2 kilogram multiplied by velocity of car B after collision. 0.5 kilogram meter per second plus 0.14 kilogram meter per second is equal to 0.5 kilogram multiplied by velocity of car A after collision plus 0.2 kilogram multiplied by velocity of the car B after collision. 0.5 kilogram times velocity of car A after collision plus 0.2 kilogram times velocity of car B after collision is equal to 0.64 kilogram meter per second. Then we get the velocity of the two cars after the collision. The velocity of car A is equal to 0.55 meter per second and the velocity of car B is 0.85 meter per second.
Kinetic energy of car A after collision. Given. Velocity of car A is equals to 0.55 meter per second and the mass of car A is equals to 0.5 kilogram. Formula. Kinetic energy is equals to 1 half mass velocity squared. Solution. Kinetic energy is equals to 1 half times 0.5 kilogram times 0.55 meter per second squared. Kinetic energy is equals to 1 half times 0.1513 kilogram meter per second squared. The total kinetic energy of car A is equals to 0.0756 joules.
Kinetic energy of car B after collision. The given are velocity of car B after collision, which is 0.85 meter per second, and the mass of car B, 0.2 kilograms. The formula to get the kinetic energy of car B is equal to 1 half times mass times velocity squared. Solution. 1 half times 0.2 kilogram times 0.85 meter per second squared. 1 half times 0.1445 kilogram meter per second square. Then we get the kinetic energy, which is the 0.0723 joules. The total kinetic energy of car B and car A after collision is 0.15 joule.